Dear viewers, you are welcome to another class of calculus. One of the important topic is integration. Today I will teach you the integration. Like derivative, integration is also a mathematical process. Different mathematical processes. Similarly, integration is also a mathematical process or mathematical operation. But now I will teach you what actually this operation does. Derivative of sin x is equal to cos x. That means when we differentiate sin x, we find cos x. That means there is a mathematical process which gives cos x from sin x, and that process is differentiation or derivative. That means we reach from sin x to cos x by the process is differentiation. Differentiation is a process which gives cos x from sin x. That means sin x to cos x. This process is differentiation. If there is a process from sin x to cos x, if there is a process to find cos x from sin x, so there must be another process by which we can find sin x from cos x. That means this is the process is differentiation. Then which is from sin x to cos x. Then the process from cos x to sin x. The process by which we can find sin x from cos x is the inverse process of differentiation, the inverse process of derivative. This inverse process by which we can travel from cos x to sin x is the inverse process of differentiation or derivative, which is known as integration. So dear viewers, integration is the inverse process of derivative. So we can define integration is the inverse process of derivative. So integration is the inverse process of derivative. It is also known as antiderivative. As it is the inverse process of derivative, it is also known as antiderivative or primitive. Integration is otherwise known as primitive. The other name of integration is also primitive or antiderivative. Now let derivative of g of x is f of x. That means g of x is a function, f of x is a function. Suppose the derivative of g of x is f of x. That means when we move from g of x to f of x, one function gx to another function f of x, the process is differentiation or derivative. So the inverse process of differentiation which can move from f of x to g of x is the integration. That means if derivative of g of x is f of x, then we can say integration of f of x is g of x. Derivative of g of x is f of x, so integration of f of x is g of x. Now I want to define integration in another way. First definition is the inverse process. Another way is, look at here, derivative of sin x is cos x. Then we can say integration of cos x is sin x. That means we are integrating cos x, means the derivative of sin x. So we are integrating cos x means we are integrating the derivative of a function. So here integrating cos x and we are obtaining sin x. That means we integrate cos x and we find sin x. We integrate the derivative and find the function. This is a process where the derivative is given and to find the given function. That means integration is a process to find a function, whose derivative is given. Integration is a process to find a function whose derivative is given. So the another definition of integration is a process to find a function whose derivative is given. Here we have given cos x, that means derivative is given. And we find sin x, that means the function. So the another definition of integration is it is a process in which to find a function whose derivative is given. The symbols is like this. Let derivative of g of x is equal to f of x. Then integration of f of x with respect to x. Here the variable of integration is x. Then we can say if derivative of g of x is equal to f of x, then the integration of f of x with respect to x is equal to g of x. If derivative of g of x is equal to f of x, then the integration of f of x is g of x, but I write here the integration of f of x with respect to x is equal to g of x plus c. Why? is there plus c. I will describe it after some time. Now look at here, the integration of f of x, symbolically we write it as the integration of, this is the symbol of integration, integration of f of x with respect to x is here. In integration of f of this is read as integration of f of x with respect to x is equal to g of x plus c. But practically integration of f of x is equal to g of x. Why there is c? First I want to show you, this is the symbol or sign of integration. This is elongated s like this. This is the symbol or sign of integration. Now here we are integrating the function f of x. This function which is to be integrated is known as integrand. The function which is to be integrated is known as integrand, and this is the dx, and x is here variable of integration, variable of integration, and g of x is the integral. This is the integral of f of x, and c is the constant of integration. You will find a constant in every integration. Integration is a process. Integrate means to find the integral. So this is a process where we find the integral. So integrate means to find integral. Now why there is a c here? Look at here. Derivative of g of x is equal to f of x. If we take derivative of g of x plus 1, then derivative of g of x is f of x, but derivative of 1 is 0. Similarly, if we take derivative of g of x plus 2, then derivative of g of x is f of x plus derivative of 2 is 0. Similarly, if we take derivative of g of x plus any constant c, then this is also f of x. So look at here, integration of f of x. If derivative of g of x is f of x, then the integration of f of x with respect to x is equal to g of x. Derivative of g of x is f of x. So integration of f of x is gx. Now here derivative of g of x plus 1 is f of x. So integration of f of x is equal to this, that means g of x plus 1. Here derivative of g of x plus 2 is f of x. So integration of f of x is g of x plus 2. Here we find integration of f of x is g of x plus 2, and here 1, 2, 3. If you take derivative of g of x plus 1 plus 2 plus 3, then you find the derivative is f of x. Then what is the integration of f of x? The integration of f of x, the integration of f of x is g of x. From here is g of x plus 1, from here is g of x plus 2. So integration of f of x is g of x plus 0, g of x plus 1, g of x plus 2. So that's why we take the integration of f of x. It will better to write integration of f of x is equal to g of x plus c, where c is the arbitrary constant. It may be 0, here is 0, here is 1, here is 2. So if derivative of g of x is f of x, then the integration of f of x with respect to x is equal to g of x plus c. This is the symbolical representation of integration. Derivative of g of x plus c is equal to f of x, which implies integration of f of x with respect to x is g of x plus c. This c is arbitrary. This c is arbitrary. If you take c is equal to 1, then gx plus 1. If 2, gx plus 2. If 3, gx plus 3. So as this c is arbitrary, then the integration gx plus c is not unique. That means there are different values of integration. Gx plus c is arbitrarily many. So as c is arbitrary, the integration is not unique. So as the value c is indefinite, then this type of integration is known as indefinite integration, indefinite integral. And if you can put c a particular value, suppose 5, then gx plus 5. So gx plus 5 is a particular value, particular integral. This is known as a definite integral. So in integration, if the arbitrary constant is present, then this integration is indefinite integral, and if there is a particular value assigned to c, then that is definite integral. So there are two types of integral, one is indefinite, another is definite. Now the formulae of integration, there are different formulas in integration. The first formula is the integration of x to the power n with respect to x is equal to x to the power n plus 1 upon n plus 1 plus c. So how can we prove this? We have derivative of x to the power m is m into x to the power m minus 1. We have derivative of x to the power m is m into x to the power m minus 1, which implies integration, which implies derivative of x to the power m by m, constant, divide constant here, is x to the power m minus 1. Put m minus 1 is equal to n, implies m is equal to n plus 1. Putting here we find derivative of x to the power m is n plus 1 divided by m is n plus 1 is equal to x to the power m minus 1. M minus 1 is n. So derivative for this mass is equal to x to the power n. If derivative of this is x to the power n, which implies integration of x to the power n with respect to x is x to the power n plus 1 by n plus 1 plus c. I have already said for every integration there will be a c here. So integration of x to the power n is n plus 1 by n plus 1. But look at here, the quotient is the denominator. Look at here, the denominator is n plus 1. So n plus 1, so n plus 1 cannot be equal to 0, which implies n cannot be equal to minus 1. So the only restriction, there is important restriction in this formula is n is not equal to minus 1. This formula can be applied for every value of n, but when n is equal to minus 1, this formula cannot be applied. This is the only restriction to apply this formula. Integration of x to the power 3 is x to the power 4 by 4 plus c, because x to the power 3 n is 3 here, and this is x to the power 3 plus 1. Integration of x cube dx, here is x to the power n is 3 here, and the formula, the integration is x to the power n plus 1 means 3 plus 1 by 3 plus 1 plus c, which is equal to x to the power 4 by 4 plus c. Integration of x to the power 50, we can directly solve it, x to the power 51 by 51 plus c. If there is the integration of x to the power, here is integration of 1 by x to the power 5, that means this is x to the power minus 5 with respect to x, and n is a minus 5, that means x to the power minus 5 plus 1 by minus 5 plus 1 plus c, and you can solve it to find the answer. And next is integration of root x. This is integration x to the power 1 by 2, and is x to the power 1 by 2 plus 1 by 1 by 2 plus 1 plus c, which is equal to 2 by 3 into x to the power 3 by 2 plus c. Derivative of root x is equal to 1 by 2 root x, which implies if derivative of root x is equal to 1 by 2, now derivative of root x is equal to 1 by 2 root x. So multiply this 2 here, that means we find the derivative of 2 root x is equal to 1 by root x. If derivative of 2 root x is equal to 1 by root x, then integration of 1 by root x, integration of 1 by root x is equal to 2 root x plus c. Again, derivative of 1 by x is equal to minus 1 by x square. If we multiplied minus 1 on both sides, so this will be minus 1 and this is plus. So we know derivative of 1 by minus 1 by x is 1 by x square. So integration of 1 by x square with respect to x is minus 1 by x plus c. So these are the two formulas for quick application. These are the two formulas for quick application. So we find integration of x to the power n is equal to x to the power n plus 1 by n plus 1. If we take n is equal to minus 1, then we can't apply this formula. So if n is equal to minus 1, then x to the power minus 1 is 1 by x. How can we integrate 1 by x? So integration of 1 by x is equal to ln mod x plus c. We know derivative for ln x is 1 by x. So integration of 1 by x is ln mod x plus c. How can we find this? Look at here, if x is positive, then derivative of ln x is 1 by x. If x is negative, then derivative of ln minus x, because x is negative, so minus of x is negative, minus and minus of minus is plus, so it is ln minus x is 1 by minus x into derivative of minus x, and this is equal to 1 by minus x into minus 1 and is 1 by x. We find derivative of ln x is 1 by x, derivative of ln minus x is also 1 by x. So what is the integration of 1 by x? So integration of 1 by x from these two equations, integration of 1 by x with respect to x is ln x, and also ln integration of 1 by x with respect to x is ln x is here is ln minus x. Combining these two is ln plus x minus x. That means this is ln mod x, because mod x is plus x and minus x plus c. So this formula can be applied only when x is positive, x is negative, x is not equal to 0. So the restriction of this formula is x not equal to 0. We know derivative of a to the power x by ln a is a to the power x. So integration of a to the power x is equal to a to the power x by ln a plus c. And we know a is not equal to 1, because if a is equal to 1, then the value of ln 1 is 0 and the denominator can be 0. That's why a is not equal to 1, and logarithm of negative value doesn't exist. That's why a is positive. So the restriction of this formula is a is not equal to 1 and a is positive. Very important thing to remember. Very important thing to remember. What is the restriction of this formula? Next is derivative of e to the power x is e to the power x. So integration of e to the power x is also e to the power x. So the only formula whose integration is itself, whose derivative is itself, is the function e to the power x, the exponential function. And here we know derivative of sin x is cos x. So integration of cos x is sin x. Derivative of cos x is minus sin. Derivative of cos x is minus sin x. So derivative of minus cos x is sin x. So integration of sin x is minus cos x. Derivative of tan x is sec square x. So integration of sec square x is tan x. Derivative of minus cot x is cosec square x. So integration of cosec square x is minus cot x plus c. Derivative of sec x is equal to sec x into tan x. So integration of sec into tan is sec x plus c. Derivative of minus cosec x is equal to cosec x into cot x. So integration of cosec x into cot x is minus cosec x plus c. So these are some simple formulas. Other formulas are, we know derivative of sin inverse x is 1 by root over 1 minus x square, and derivative of cos inverse x is minus 1 by root over 1 minus x square, and derivative of minus cos inverse x is 1 by root over 1 minus x square. So the integration of this 1 by root over 1 minus x square is sin inverse x plus c or minus cos inverse x plus c. And second is derivative of tan inverse x is 1 by 1 plus x square. Derivative of minus cot inverse x is 1 by 1 plus x square. So integration of 1 by 1 plus x square is tan inverse x plus c or minus cot inverse x plus c. Similarly, we know derivative of sec inverse x is 1 by x into root over x square minus 1, and derivative of minus cosec inverse x is also this. So integration of 1 by x into root over x square minus 1 is sec inverse x plus c or minus cosec inverse x plus c. So these are the fundamental formulas for integration. Next is algebra of integration. Like derivative, integration also obeys the linear property. That means we know derivative of f plus g is derivative of f plus derivative of g, where f, g are both functions of same variable. Here is also integration of f of x plus g of x is equal to integration of f of x plus integration of g of x. That means if f1, f2 up to fn, suppose these are n functions of variable, single variable x, all are the functions of x. So integration of f1 plus minus f2 plus minus up to fn dx is equal to integration of f1 dx plus integration of f2 plus integration up to fn. That means this is the linear property. So application of this is, suppose you have to integrate f of x plus g of x dx, then this is integration of f of x dx plus integration of g of x dx. And this rule is same for subtraction. If we replace addition by subtraction, this, then here is also subtraction. This is the addition and subtraction formula. And second is the constant multiplication. Constant multiplication means like derivative, when a constant is multiplied with a function, that means the integration of a constant into a function is equal to constant into integration of that function. If any constant is multiplied with a function, then you can take it outside of the integration. See, this remains constant throughout the process. problems on integration. The first question is to integrate ax square plus bx plus c with respect to x. Now this is integration of ax square with respect to x plus integration of bx with respect to x plus integration of c with respect to x, which implies a is constant here, so a into integration of x square plus b is constant here, b into integration of x, and c is constant here is dx. Now a into integration of x square is x cube by 3 plus b into integration of x is x square by 2 plus c into integration of dx is x, plus we can take a constant here, the constant is k here. So this is the integration. Another question is to integrate a square of root x minus 1 by root x with respect to x. Now this is, we can apply here square of a minus b whole square. This is a square means square of root x is x plus b square is square of 1 by root x, and this is 1 by x, a square plus b square minus 2 a is root x into b is 1 by root x. So this is equal to integration of x first, addition formula apply. Here we apply addition and subtraction formula. Integration of x first plus integration of 1 by x minus here is the integration of 2, and integration of x is x square by 2 because x for 1 is here, plus integration of 1 by x is ln mod x minus 2 is constant, and integration of dx is x plus c, integration of dx is x. Now another question is to integrate 2 minus 3 sin x upon cos square x dx. So now we can write it as integration of 2 by this is cos square x minus 3 sin x by cos square x dx, and this is equal to integration of 2 by cos square x is 2 into 1 by cos square x is sec square x minus 3 into sin by cos square. So sin by cos is tan x into 1 by cos x is sec x. Now we can apply the subtraction formula here. So now we find 2 is constant here, 2 into integration of sec square x with respect to x minus 3 is constant here, goes outside of the integration, 3 into integration of this is sec x into tan x dx. So this is 2 into integration of sec square x, we have formula is tan x minus 3 into sec x into tan x. You know derivative of sec x is sec x into tan x, so integration of sec x into tan x is sec x. This is 3 into sec x plus c. Overall you have to add a constant at the end of integration. Another question is integration of 1 by 1 minus cos square x dx. This can be written as 1 by, 1 minus cos square x is sin square x with respect to x, and this is 1 by sin square x is cosec square x, and this is equal to integration of cosec square x is minus cot x plus c is the direct formula. Another important question is to integrate cos to the 4x minus sin to the 4x by cos x minus sin x with respect to x. And now here we can apply the formula a to the power 4 minus b to the 4, which is a square plus b square into a plus b into a minus b. You know in high school standard this is the formula for a to the 4 minus b to the 4. Here a is cos x and b is sin x. So if you apply this formula you will find this is a square plus b square means cos square x plus sin square x into a plus b means is cos x plus sin x, and is a minus b. A minus b is here cos x minus sin x whole divided by, you have to apply this is cos x minus sin x. Look at here, we can cancel the equal term cos x minus sin x, and here remains cos square x plus sin square x is 1, and this is 1 into this term cancels and remains cos x plus sin x. Now you can apply here the addition formula. The derivative integration of cos x, the integration of cos x is sin x plus integration of sin x is minus cos x plus c is the integration. Another integration is to find the integral of tan x plus cot x to the power 2 dx, and now this is here we can apply the formula whole square of a plus b, and this is in a square means square of tan x and is tan square x plus a square plus b square means this is cot square x plus 2ab means 2 into tan x into cot x dx. Look at here. We have the formula for sec square x, but there is no formula for tan square. We have formula for cosec square x, but there is no formula for cot square x. Remind one important thing throughout integration, where you will find tan square, then just apply the formula tan square is sec square minus 1. Anywhere you find cot square x, then you can apply as cosec square minus 1. Remind here throughout integration where you are solving the integration problems, if you find tan square, then just put sec square x minus 1 in place of tan square and put cot square x equal cosec square minus 1, because we have no formula for tan square cot square, but we have the formula for integrating sec square and cosec square x. So you have to apply tan square everywhere. You have to apply tan square is equal to sec square minus 1 and cot square is equal to cosec square minus 1. These are the two important tricks. Tan square is sec square x minus 1 plus cot square x is cosec square x minus 1 plus tan into cot is 1. This is 2. So minus 1 plus 2 cancels and it remains integration of sec square x, and I am writing here integration of sec square x is tan x plus integration cosec square x is minus cot x plus c is the answer. Here is another question to integrate a to the power x plus 2 with respect to x. Now we can write it as a to the power x into a to the power 2 with respect to x. We know x to the power m plus n is equal to x to the power m into x to the power n. So likewise, now here look at a to the power 2 is the constant, a square comes outside of integration and remains integration of a to the power x, which is equal to a square into, and integration of a to the power x is a to the power x by ln a plus c. This is the formula, and you have to, first thing is you have to learn all the formulas, then you can apply easily. Another question is to integrate x to the power 6 upon x square plus 1 dx. It's a very important problem. Another important trick you have to apply here. Look at here, the degree of a numerator is 6. That means the highest power of x is 6 here in the numerator, and in the denominator the highest power of x is 2, and degree of a numerator is greater than degree of a denominator. If degree of a numerator is greater than degree of a denominator, then you have to divide, or you have to adjust in such way that this can be factorized. Two ways to solve this problem. First is to divide, and I am showing here two methods. First I want to adjust it. Now look at here, x to the power 6 plus 1 minus 1 by x square plus 1 dx, which is equal to, this is x power 6 means this is square of x cube plus 1 minus 1 by x square plus 1, and which is equal to, now this 1 is 1 cube. Now I can apply a formula here, a cube plus b cube, and which is the integration of a cube plus b cube means a is your x square, a plus b into a square means square of x square is x to the power 4 minus ab is x square into 1 is x square plus b square means square of 1 is 1 minus 1 whole divided by x square plus 1. Now this is the term x square minus 1, the term x square plus 1 x square plus 1 is cancelled. Now integration of it remains x to the power 4 minus x square plus 1 minus 1 by this is x square plus 1. X square plus 1 is cancelled in this term, but it remains here 1 by x square plus 1, and the integration of x to the power 4 is x to the power 5 minus integration of x to the power 4 is x to the power 5 by 5. Integration of x to the 4 is x to the 5 by 5 minus integration of x square is x cube by 3 plus integration of 1 means integration of dx is x minus 1 by x square. The integration of 1 by 1 plus x square is tan inverse x plus c. So this is the answer. Another trick is you can divide x to the power 6 by x square plus 1. So if you divide this, then you will find the quotient as x to the 4 minus x square plus 1 and the remainder is minus 1. But we know that the dividend is divisor into quotient plus remainder. Dividend is equal to divisor means x square plus 1 into quotient is x to the 4 minus x square plus 1. Dividend is equal to x power 6 is equal to divisor into quotient plus the remainder means minus 1. So also by dividing you can also factorize this term. So these are the two tricks you can apply to find this type of problems where degree of a numerator is greater than degree of a denominator. Now the properties of integration. The first property is the process of a differentiation and integration are inverse to each other. I have already said from the beginning that integration is the inverse process of derivative. Similarly, derivative is also inverse of integration. Derivative is inverse of integration. Integration is inverse of a derivative. Both are inverse to each other. How? Look at here. That is, these two processes are inverse to each other. That is, derivative of integration of a function is the function itself, but integration of a derivative function is the function plus the arbitrary constant c. How? Look at here. Suppose derivative of a capital F. Here there are two functions. One is capital F and another is small f. Suppose derivative of capital F of x is equal to small f of x. These are two different functions. So if derivative of capital F is small f, if derivative of capital F is small f, then the integration of small f is capital F. So integration of f of x is equal to capital F of x plus c, which implies differentiating both sides. Derivative d by dx of integration of f of x dx is equal to d by dx of f of x plus c, which is equal to, we can apply addition formula here. That means derivative of f of x plus derivative of c, but we know derivative constant is 0, so this is derivative of f of x. So which implies we find derivative of integration of f of x dx is equal to derivative of f of x. So derivative of f of x is small f of x is f of x. So derivative of integration of a function is the function. Next is, here we find it derivative of integration. Next to find integration of a derivative. Now f dash x means derivative of f of x. Integrating both sides, integration of f dash x dx is equal to integration of d by dx of f of x, which is equal to, we know integration and of a function, these two are inverse. That means integration of a derivative is f of x, but for integration we have to add a constant. This is f of x plus c. So we find two important things. Derivative of integration, here is integration of a derivative. Derivative of integration is function, but integration of a derivative is function plus constant. These two are inverse to each other, but like this they appear like this. Another property, integration of derivative of a function minus derivative of integration of a function is a constant c. How? Look at here. Integration of a derivative of a function is function, derivative of integration of a function is function. But look at here, when we find the integration of this, that means integration of a derivative, this will be f of x. But as there is integration here, so you have to find that there must be some integration, there must be a constant of integration minus. Look at here what happens, derivative of integration. So derivative of integration is the function, but when you are integrating there must be a constant, but the derivative of the constant is 0. So now this is c. So these two quantities differ by a constant c. Here is the comparison, derivative versus integration. First is, both are operation on functions. These two are operations, these two are operating and they are inverse operations. Next is, both satisfy linear property. Both satisfy linear property means both satisfy addition, subtraction and constant multiplication. That means derivative of f plus g is derivative of f plus derivative of g. Integration of f plus g is integration of f plus integration of g. And similarly for addition, and similarly for subtraction. And next is constant multiplication. Derivative of a constant into function is constant into derivative of that function, and same process and same procedure applies for integration. So these two, derivative and integration, satisfy the linear properties. Next is the third property. All functions are not differentiable. We have already learned, we have already tested the differentiability. Every function is not differentiable. Similarly, every function is also not integrable. The fourth property is the derivative of function is unique, but the integration of a function is not unique, is arbitrarily due to the presence of arbitrary constant. Take an example. You know derivative of tan x is sec square x. So if you differentiate tan x, you will find sec square x. So sec square is the only function which is the derivative of tan x. So derivative of tan x is unique, which is sec square x, only one. But if you integrate sec square x, you will find tan x plus c. C is arbitrary constant. That means integration of sec square x is tan x plus c. If you take c is equal 1, then tan x plus 1. If you take c is equal to tan x plus 2, for different values of c, you find different integrations. Tan x plus 1, tan x plus 2, like this, infinitely many. So that's why the integration of a function is not unique. The next property is, if f of x is a polynomial, if you take a polynomial function, then the derivative, if you take a polynomial function, suppose f of x is a polynomial function whose degree is n, then if a polynomial is of degree n, then the derivative, then the degree of its derivative is n minus 1 and the degree of its integration is n plus 1. How? Suppose you take a polynomial x cube whose degree is 3. If you take differentiate it, then you will find derivative. Let us take an example here. Suppose you are taking x cube, derivative is 3x square, integration is x to the 4 by 4. So a polynomial of degree 3, derivative is degree 2, but integration is degree 4. So if a polynomial is of degree n, then the degree of its derivative is n minus 1 and the degree of its integration is n plus 1. In case of a derivative, the degree decreases by 1. In case of its integration, the degree increases by 1. And this is only for polynomial function. And the next is derivative of a function can be obtained at a point. We have already tested. We can differentiate a function at a particular point, derivative at a point, but we cannot find the integration of a function at a particular point, particular given point. But the integration of a function can be found in an interval, not at a point. Next property is the geometrical meaning. Geometrical meaning of a derivative is rate of change or slope of tangent, as we have already discussed in its definition. And the geometrical meaning of integration is the formula for curves having parallel tangents, and also it is used to determine the area under plane curves. This family of curves is obtained. This is the geometrical meaning of integration in case of indefinite integration. As we know, there are two types of integration. One is indefinite integration, another is definite integration. And the geometrical meaning of indefinite integration is this, and the geometrical meaning of definite integration is to find the area under plane curves. Next is the derivative. This is to find velocity and acceleration, but integration is used to find distance when velocity is given or to find velocity when acceleration is given. Then the last property is the derivative and integration both involves limit. When we evaluate differentiation of a function, we use limit. Also, integration is the nth partial sum of limit. That means these two operations involves limit.